Alright, so here we have this problem with the model car, the 1/32nd length of the original car. And the original car is 288. We wonder how long is the model. So what I would do if I was solving this is I'd say that 1/32, so that's the model to the original, is equal to some length of the model to the length of the original. So when I cross multiply, I get 32x equals 288 inches. So when I divide both sides by 32, x would be 9 inches long. Now the key piece with this one, looking at the common flag that's 4 feet by 6 feet wide, and we want to change it to make it fit on this paper, is that here we have feet, here we have inches. So we have to convert one of these either from feet to inches or inches to feet. And I know that 4 feet by 6 feet is equivalent to 48 inches by 72 inches. And how do I know that? If I use my methods of conversion, I'd end up multiplying both of those by 12 inches over 1 foot to cancel out. So what I know is that this is 8 inches is related to the height. So I know that the 48 inches of the actual flag compares to 8 inches of the poster he's going to make. So 72 inches of the actual flag will compare to whatever width he needs. So this will give me 48 inches times x will equal 576, and that's inches times inches, so that's inches squared. But I'm going to divide both sides by 48 inches. So I can say that my inches cancels out one of those, leave me just with a single unit of inches, and x would be 12 inches wide. Now here I have a problem where I have both feet and inches again, and so I need to figure out which way do I want to go. And so the easiest thing to do would be to take her overall height and change it into inches. So that is 4 feet plus 3 inches. Well, 4 feet we just said was 48 inches, plus the 3 additional inches would mean that Jasmine is 51 inches tall. So if I want to figure out how to make her arm, I know that I have her 51 inches in actual height compared to 15 inches in the picture. So her 20-inch arm would have to follow the same proportion. So here I have that 51 inches times x will equal 300 square inches, and I divide both sides by the 51 inches, and here my inches cancels one of the squares, and then 300 divided by 51 is going to give me approximately 5 88/100 inches for the length of her arm. So just under 6 inches for the length of her arm in her picture. Now with the last problem, we're going to use a shadow and see what we can create in trying to figure out. So this one will be helpful both to pay attention to how do we relate the measurements, but also how do we set this up. So I'm going to draw a picture to help out here. So Thales is a 6 foot tall Greek mathematician. So here's Thales, and he's 6 feet. And one day his shadow is 2 feet 3 inches. So there's 2 feet 3 inches. And then he knows the tree has a shadow. So here's a tree, and it has a shadow that is 27 feet 6 inches. And he wants to know how tall is the tree. Now, what is nice here is if we draw in this side, what we end up with, because of the way the sun is beating down on them both at the same place, we have two similar triangles. So what we can say is that the 6 feet compared to x will equal the 2 feet 3 inches compared to the 27 feet and 6 inches. Now, those measurements are kind of hard to deal with in that case, so it's easier to convert them over to all feet or all inches. It's whichever you want to do. So if I do that, I know this again would be 6 feet over x. 2 feet 3 inches is the same thing as 2 3/12 feet, and 2 3/12 feet is the same as 2 1/4 all feet, and 6 inches is half of a foot, so I can say this is 27.5 feet. Now I can cross multiply and get 165 square feet is equal to 2 1/4 feet times x. So I divide both sides by the 2 1/4 feet. And I know that the feet will cancel that feet squared, leaving me just with a single foot. And then when I divide 165 by 2 1/4, I get 73 1/3 feet. And if I convert a 1/3, a third of a foot would be 73 feet and 4 inches.